Hello students, welcome back to chemistry class. In the previous class, we have discussed hydrocarbons and today we are moving on to the next topic, it is functional groups. What are functional groups? Children, in the hydrocarbon chains, if carbon is shared its electrons with some other atoms, some other heteroatoms like sulfur, nitrogen, oxygen, etc., that will change the entire property of the hydrocarbons. Okay, they are called functional groups. So what are functional groups? In a hydrocarbon chain, the heteroatoms like sulfur, nitrogen, oxygen or any other halogens, if it present, it will change the entire property of the hydrocarbon chain. They are known as functional groups. Let's have a small introduction regarding functional groups and what are functional groups, etc. we will learn in this video. Okay.
Functional groups. What are functional groups? In daily routine, you want to become a healthiest person in day-to-day life. The things which are present in our body, most of them are organic in nature. Okay, for the development and growth, and you have organic components in your body. Okay, what are they? Carbohydrates, fats, proteins, nucleic acids. These all are organic compounds. Students, you have already learned the compounds of carbon and hydrogen are known as hydrocarbons. These hydrocarbons are mostly present in petroleum products, and these hydrocarbons have derivatives also. These derivatives are called functional groups. Okay, look at here. This is hydrocarbons you have already learned. Okay, these hydrocarbons, if it replaced by another heteroatoms which are called functional groups. Okay, these are the functional groups we are moving to study. So let us discuss the first functional groups, that is carboxylic acid. Okay, in a hydrocarbon, if carbon is doubly bonded with oxygen atom and singly bonded with hydrogen and alkanes, so that is the carboxylic acid. So RCOOH is the functional group of carboxylic acid. Okay, can you see the formic acid? Yes, the irritation which is caused after rancid and nettle is due to the formic acid. So you can see the acids are present in different components like this. Okay, everywhere carboxylic acids are present. Okay, coming to the next functional group, it is alcohol. So in the hydrocarbon chain, if oxygen comes as a heteroatoms, instead of one hydrogen, if oxygen comes, so it is called methyl alcohol or methanol. Okay, if two carbon atom, one H is replaced by OH group, it is ethanol. Ethanol is commonly seen in wine and beer. It is a natural alcohol. Okay. Aldehyde is a functional group you can see commonly in almond and vanilla leaf. CHO is a functional group. And the next functional group, it is ketone. If carbon is attached with one oxygen, so it is ketone. You can commonly see in mushrooms and strawberries.
Okay students, I hope you got a small idea regarding functional groups. Okay, so now let's discuss the functional groups one by one and let's study what happens these functional groups comes in the hydrocarbon chains. Okay, so if the heteroatoms like chlorine or bromine, these are halogens, is present in a hydrocarbon chain, okay, generally you can say it is X. X can be either chlorine or bromine, iodine or fluorine, whatever chlorine. If it present in a hydrocarbon chain like ethane, propane, butane, etc., that will change the properties of the hydrocarbon. Okay. If the functional groups like aldehydes, ketones, carboxylic acids and alcohol, look at here. What is common in these functional groups? You can see oxygen as a heteroatoms. In a carbon chain, if oxygen has come like this, CHO, it is the aldehyde functional group. So the suffix you have to add in the chain as al. If ketone group means one oxygen atom will be present in between the two carbon chain. If CO group is present, the suffix should be added in the chain. It is ketone. The suffix is on. So what is carboxylic acid? In a hydrocarbon chain, if 2 oxygen atom is present, so the functional group is known as oic acid. So finally, alcohol, which is common. In a hydrocarbon chain, if oxygen atom is present like this, 1 oxygen and 1 hydrogen, so which is alcohol functional group, and the suffix should be added, that is ol. Okay, now let us discuss one by one. First, let us take first halogens. So halogens like chlorine or bromine, any halogen, first let us take. For that, first I'll show you how to write it. So this is methane, the first member of alkane series, methane. So what I am going to do is, I just remove 1 hydrogen from here. Instead of hydrogen, I'll add any one halogen. Suppose if I add chlorine here, how will I name this compound? You know that already the chain was methane, right? From the methane, I just remove the hydrogen and I just added chlorine. So the word root is meth. The hydrocarbon is meth. The word root is meth. And what suffix should be added? Is it suffix? No. You have to add a prefix. The prefix chloro. Chloromethane. Okay? From the methane, 1 hydrogen is removed and you have added chlorine. So you have to call the compound chloromethane. Okay. How will I draw chloroethane? Draw 2 carbon. Replace 1 hydrogen and add chlorine. So this was already ethane chain. So chloroethane. From the ethane, 1 hydrogen is removed. So you got chloroethane. So you can draw chloropropane, chlorobutane, etc. So okay. Only in the case of halogens you have to add prefix, but rest of the functional groups you have to add a suffix. I will show you how we will fix the suffix over there. First let me take aldehyde functional group because oxygen is the heteroatom. Same compound, the first member of alkane series. If I take methane, from the methane, if I remove 1 hydrogen, and if I add 1 heteroatoms here, again you have to remove 1 more hydrogen. 1, 2, 3, 4. 4 hydrogen. Sorry, 4 valencies with 1 heteroatom. So what is the name of the compound? The word root is meth, since it is 1 carbon. Meth. Right? Along with meth, you have to add the suffix. How will you add the suffix? What is the suffix of aldehyde? It is al. CHO is al. So, this is methane ring, right? This is the methane compound. From the methane compound, you have removed hydrogen. And when you write the name, just remove the E and add the suffix. It is methanol. The name of this compound is methanol because 1 carbon atom with the oxygen functional group. One carbon atom with the aldehyde functional group. How will you draw ethanol? Since it is eth, 2 carbon. So 1 carbon is aldehyde and the rest will be satisfied by hydrogen. 2 carbon with the aldehyde functional groups. So it is ethanol. Okay. So you can draw the chain methanol, ethanol, propanol, butanol, pentanol, hexanol, etc. so on. Okay. If keto group is coming in between the carbon atom, you have to call the suffix on. If keto group was present in a hydrocarbon, so minimum carbon should be required. So the keto group will come in between the 2 carbon atoms. Then satisfy the valency. The rest of the valencies should be satisfied. So the ketone family will be started with the propanol. So how will you name this compound? 3 carbon. It is prop. The functional group is CO. CO group suffix is on. So the name will be propanon. How will you draw butanon? Draw 4 carbon. Anywhere in between 2 carbon atom, draw keto functional group and satisfy the valencies. Have to check it. The valencies has to be satisfied. How will you name this compound? Since it is 4 carbon atom, the word root is butanon. Because keto functional group CO, so the name is butanon. So the chain will be continuously going like this: butanon, pentanon, hexanon, etc. Okay? And what is the next heteroatom, next functional group? It is carboxylic acid. If I take what is the functional group? COOH. So this functional group is carboxylic acid functional group and the suffix is oic acid. Count the number of carbon atom. 2. So word root is ethanoic acid. Eth plus oic acid. E should be removed from ethane and oic acid suffix should be added. So the ethanoic acid. COOH group is carboxylic acid. How will you draw the propanoic acid? Draw 3 carbon. 1 carbon should be oic acid. COOH. And rest of the valencies should be satisfied. Like this. And this is the propanoic acid because 3 carbon with the carboxylic functional group, propanoic acid. We can draw butanoic acid, pentanoic acid, hexanoic acid, etc. Okay? Okay. And the last functional group, it is alcohol. Alcohol is the OH functional group. So in a hydrocarbon chain, if I take methane, so one H is removed and OH is replaced. H is replaced and OH is fixed. So how will you name the compound? The word root is meth. From methane, one H is replaced by OH. So the word root is meth and the suffix is all. Since it is OH alcohol group, the suffix is all. So methanol. So how will you draw propanol? Draw 3 carbon and 1 H will be replaced by OH and the rest of the hydrogen will be satisfied in a hydrocarbon chain. Okay? Okay, 3 carbon with the alcohol functional group. It is called propanol. You can draw butanol, pentanol, hexanol, etc. so on. Okay? Okay, students, let's move on to the next topic, homologous series. How can we construct a homologous series? Okay, you have already learned alkane series, functional group series, etc. so on. So, homologous series is the group of organic compounds in which they have similar chemical formula and similar structures and which are differ by CH2 group from top to bottom. Okay, so if I write the first aldehyde, like if I write methanol here, the next member will be ethanol. And the next member will be propanol. Propanol. Okay. In this series, what is the difference? Yes. Here you can see when methanol turns to ethanol, one CH2 has come extra. When it turns to propanol, one more CH2 has to come extra, which means that in methanol, you can write CH3OH. This is the condensed formula, CH3OH. And in the case of ethanol, how can you write? CH3, CH2OH. When it comes to propanol, CH3, CH2, CH2OH. This is propanol. And if it is butanol, how will you write? CH3, CH2, CH2, CH2OH. So the successive members have a difference of CH2 in a series. So that is why the series of functional groups or the series of alkane series or alkene series, they are called the homologous series because they differ by one CH2 unit. Okay. So this is the homologous series.